Hi, my name is Samantha Reynolds, and for the Teach the Properties project slideshow, I will be doing the division properties of exponents. So let's get started. So for the division properties of exponents, there are two major topics, which is quotient of powers and power of a quotient. Now, for example 1a, I am going to be talking about the quotient of the powers property. Now, notice what happens when you divide powers with the same base. So right here, I have 2 to the 8th power divided by 2 to the 5th power. And if I write it out in expanded form, the first 5 2's are going to be reduced because they'll equal 1. So I'm just going to reduce those 5 2's. And then I'm left with 2 to the 3rd power. Now, 2 to the 3rd power is my answer. But another way to reach 2 to the 3rd power could just be simply 2 to the 8th power minus 5, and you get 2 to the 3rd. It's just a different way to do it, but they're both super simple. Now, you can use the properties for simplifying fractions to show what happens when you divide powers with the same base. Okay, so for my next example, 1b, I will still be talking about quotient of powers property. I'll just be using variables or letters t instead of the number 2 or a regular number. Now, notice what happens when you divide variable powers with the same base. So right here, I'll be dividing t to the fourth power divided by t to the 3rd power, and I'll write that out in expanded form right here, and I will reduce the first 3 t's and get 1, so I'll have 1 t left, which will equal regular t. Yeah. But another way I can reach that, which is what we did before, is just doing t to the 4th power minus 3, and I'll still get t. So it's just different ways to do it, but you get the same answer either way that you want to do it. With example 1a or example 1b, you get the same answer. Now, examples 1a and 1b both demonstrate the quotient of powers rule. So now, for the quotient of powers key concept, I have this graphic organizer, and it shows words, symbols, and examples. So let's talk about the words. Now, this is basically the basic definition for quotient of powers. So to divide two numbers with the same base, subtract the exponents, which is what we have been doing and talking about in our last few examples. You can write out an expanded form, or you can just subtract the exponents. I personally think that subtracting the exponents is a little bit easier than writing it out in expanded form, but so that's quotient of powers definition in words. Now for symbols, for any non-zero number a and integers and y integers m and p, sorry, m and p, am to the a to the m power and a to the p power will equal a to the m power minus p. So that's just how you can use in symbols. It's just the same thing as what we have been doing in our past examples before. Now here are two last examples for quotient of powers. Now, you have c to the 11th power divided by c to the 8th, and that you can do c to the 11th power minus 8 or c to the 3rd. Same thing, you get the same answer if you're going to write it out in expanded form. I just think it's a little bit easier if you do it when you're subtracting, so that's quotient of powers with the c example right here. Now for our next example, we have r to the 5th divided by r to the 2nd, and we get r to the 5th power minus 2 equals r to the 3rd power. That's how you do subtracting quotient of powers. Now, one last example for quotient of powers property. I wrote it out with some steps to make it really simple and easy for you to understand. Now, we're going to assume that no denominator equals 0, because if a denominator does equal 0, that means it will be undefined, and we can't work out a problem that's undefined, so we're just going to assume that no denominator equals 0. So this is our equation right here. X to the 7th power, and then y to the 12th, divided by x to the 6th, y to the 3rd. So our very first step is to group powers that have the same base, and that's what we did right here in red. So right here in red, you can see x to the 7th divided by x to the 6th is grouped in 1, and then our second group is y to the 12th divided by y to the 3rd, and that's also grouped in red. Now for step 2, you can tell that it's in green, so it's a different color, and now it's going to be quotient of powers. So we're going to be doing the exact same thing we've been doing in all of our past examples, which is just subtracting. So x to the 7th power minus 6, and that's grouped in 1. And now we have y to the 12th minus 3, which is grouped in another, and that's quotient of powers, which is our second step. Now for our third step, we're just going to simplify, which means like subtracting them and bringing the whole operation together, and we get xy to the 9th power, and that's our answer, xy to the 9th power. So that's quotient of powers property with all of your steps laid out, and that's how you simplify a quotient of powers property. Okay, so now we're going to be talking about power of a quotient. So for power of a quotient, this is our key concept or graphic organizer, just like how we had with quotient of power. So for power of a quotient, we have to find the power of a quotient, find the power of the numerator and the power of the denominator. That's our word's definition. Now for symbols, we have for any real numbers a and b that don't equal 0, and any integer m, which is grouped a divided by b raised to the m power. So with this, a is raised to the m power and so is b. If m is outside the parentheses right here, that means the entire equation is raised to the m power, not just a or not just b. Both a and b will be raised to the m power. Now, for examples, we have it right here. 3 divided by 5 is grouped in parentheses, and that's all raised to the fourth power. So as you can see here, 3 raised to the fourth power divided by 5 raised to the fifth. The same thing that we did here with the a, b, and m. Now this is our next example for power of a quotient. R and divided by t, which is all raised to the fifth power, and then r to the fifth divided by t to the fifth, which is the same thing that we've been doing for our last example. Now, power rules with variables. The power rule applies to variables as well as numbers. So as you can see here, I used variables here with a, b, and m, and variables here with r and t, but the power rule applies to variables as well as numbers, so it applies if you're using numbers like 3 and 5 or r and t. They're the same, and they're both it applies to both. Okay, so for our third example for power of a quotient properties, I wrote out some steps of how it's simple to understand. So our equation here is 4c to the third and then d to the third divided by 5, and it's all raised to the third power. So our first step is power of a quotient, which we will get right here. We'll take that 3 that the entire equation is raised to, and we'll bring it down to the 5. So right here will be 4c to the third, d to the third raised to the third, and then divided by 5 raised to the third. So it's power of a quotient, the entire, as our first step says, power of a quotient, the entire equation is raised to 3. Now our second step is power of a product. So it may look like it has a lot of 3's here, but don't worry, I'm going to explain that. So it has 4 to the third, and then c to the third, raised to the third, and then d to the third, raised to the third. So as you can see, power of a product, like it says in step 2, we have to just raise the whole thing to 3. And then in the denominator, 5 raised to the third power, so power of a product. And now for our third step, power of a power, which will be 64, c to the ninth, and then d to the ninth, all divided by 125. So that's power of a power, and that's our answer, 64 c to the ninth, d to the ninth, divided by 125. So that's our first example for power of a quotient. Now for our next example for power of a quotient, I wrote out some steps again, and here's our equation. 3m to the third, n to the second, and divided by 4p to the fifth, q, and that's all raised to the third power again. Now, we're going to assume that p and q do not equal 0, because as I said before, if anything in the denominator equals 0, the whole equation will be undefined, and you can't simplify an undefined equation. So for our first step, as it was before, power of a quotient. So right here, we're raising the whole thing to 3. 3m to the third, n to the second, raised to the third, and then 4p5, q, 4p to the fifth power, q, all raised to the third power. So that's our first step. Now for our second step is power of a product. Now we're raising everything to 3. So 3 to the third with m to the third, raised to the third, and then n to the second, all raised to the third, or raised to the third. And now for our third step, we have power of a power, and the answer is right here in red, which is 27m to the raised to the ninth power, and then n to the sixth raised to the sixth power, divided by 64p raised to the 15th power, and then q raised to the third. And that's our answer right there in red. And it says for our third step, power of a power, and that's our answer. So that's another really good step-by-step example of power of a quotient. Now I'm going to give you guys some examples to try. So you guys want to simplify the following problems, and some of them are quotient powers and other are power of a quotient. So I'll give you guys some time to simplify the following problems for power of a quotient or quotient of a power. Okay, so the following problems are x to the third power, y to the fourth power, and divided by x to the second power, y. So the answer to that is, well, all the answers will be in the next slide. And then k to the seventh power, and then m to the 10th power, and then k to the second, m to the third, and that's divided. That's divided by that. And the last one, 3x to the fourth power divided by 4, all raised to the third power. That was that thing we talked about before, with everything being raised to the power that if it's in parentheses. 2 more problems, 5x raised to the fifth power, y to the second, divided by 6, and that's all raised to the second power. And then for our last example, or problem, 4x raised to the third power, divided by 5y raised to the fourth power, all grouped in one, all raised to the third power. Okay, so here are the class problems and their answers. So as you can see right here with the first equation, we're going to be doing the same thing that we did with at the way beginning of this, which was quotient of powers. So this is quotient of powers. So it's going to be x to the third power minus 2 and y to the fourth power minus 1, and you get xy to the third, which is what we did right at the beginning, which was quotient of powers. Now, for the second one, it's k raised to the 7th power, m raised to the 10th power, divided by k raised to the 5th power, and m to the 3rd power. And this is the same thing as the other one, just with different, and it's quotient of powers, just like what we did, which was our first topic right at the beginning of this slideshow. And that's k to the 7th power minus 5 and m to the 10th power minus 3, which equals k to the 2nd power minus 7. Okay, for our third equation, it is 3x raised to the 4th power divided by 4, and that's all grouped with 3. That's all grouped with 3 raised to the 3rd power, and that's 3x to the 4th, in parentheses, raised to the 3rd power divided by 4 raised to the 3rd, and that explains power of a quotient. And right here, we're just explaining power of a power, which is 3 to the 3rd raised to the 3rd, in parentheses, x raised to the 4th, all raised to the 3rd, and then divided by 4 raised to the 3rd. And now we have power of a power, which is 27x to the 12th power, divided by a 64. So now we have our last two, which is 5x raised to the 5th, y to the 2nd, divided by 6, all raised to the 2nd power, which is right here, power of a quotient, 5 to the 2nd power, x raised to the 5th, raised to the 2nd, and then y raised to the 2nd, raised to the 2nd, divided by 6 raised to the 2nd. And the answer to that will be 25x to the 10th power, y to the 4th, divided by 36. And now for our last problem or example, it is 4x to the 3rd, divided by 5y to the 4th, all raised to the 3rd power. And right here we have power of a quotient, which is 4 raised to the 3rd power, and x raised to the 3rd raised to the 3rd. And now it's 5, which is y to the 4th power raised to the 3rd power. And the answer to that, which is power of power, which is 64x to the 9th, divided by 125y to the 12th. Okay, and that was my last slide. So, I'm sorry, I accidentally went back. That was my last slide. So, I hope I taught something about quotient of powers and power of a quotient and all of that stuff. So, I really hope I taught some good stuff. Okay, thank you. I'm Samantha Reynolds, and goodbye.